So we are discussing what is the relation between central moments and moments about the origin. Okay. So here x is a random variable. Then the central moment is given by mu n is equal to x of expected value of x minus x bar power n. Now what is that we are doing here? We are replacing x minus x bar power n. We are replacing x minus x bar power n with a binomial expansion. Okay. So x minus x bar power n is given as, it is summation k is equal to 0 to n minus 1 power k n c k x of n minus k x bar k. Okay. Now nck is nothing but n factorial divided by k factorial into n minus k factorial. So from this we know that nc0 will be always 1, ncn is also 1. Okay. Now what is that we are doing? We are substituting this equation x minus x bar power n. So that is the binomial approximation for this exponential. Okay, this power x minus x bar power n we are substituting here in the central moment equation. Okay. So if you substitute that in the central moment equation, now we are applying expectation. So we know that expectation, from the properties of expectation, we know that expectation of some constant into the random variable, so will be equal to a into the expectation of x, a into expectation of x. So we just identify what are the constants we have in the binomial expansion. Okay. So if you check what are the constants we have, minus 1 power n minus 1 power k is a constant, n c k is also constant, and the x bar, that is the mean value, is also constant. Okay. All these are the constant terms. Now we will be applying expectation to only this term. Okay. So we are applying expectation to x of n minus k, and all other terms will be writing outside this expectation. Okay. So it is summation k is equal to 0 to n minus 1 power k nck x bar power k expectation of x of n minus k. Okay. So now we know that what is a movement about the movement about the horizon. Okay. So movement about the horizon we denote it as mn. So mn is equal to what? It is expectation of x power n. Okay. So it is the expectation of x power n. Okay. And we also know that the first moment m1 is nothing but it is expectation of x. Okay. So the power is 1. So it is nothing but expectation of x. So we also know that expectation of x can also be represented as x bar. Okay. We also write it as x bar here. Okay. So in the previous equation, if you observe, okay, see this equation. If you observe, what is x bar? X bar is nothing but m1 x bar. Here we have x bar, no? So x bar is nothing but m1. So this is nothing but m1 power k. Okay. Now x power n is mn. So what is mn? Expectation of x power n. Now in the place of n, what we have? N minus k. So what this becomes? Mn minus k. This becomes mn minus k. Okay. So now we write that in the equation. So the this equation will be written like this: expectation of x minus x bar power n is nothing but mu n. It is equal to summation k is equal to 0 to n minus 1 power k n c k. So x bar is nothing but m1, just now we have discussed. It is m1 power k, and expectation of x power n minus k, expectation of x power n minus k, we are replacing it as mn minus k. Okay. Now this is the expression we use to obtain the relation between. So what is mu? Mu is called the central moment. Mu is called the central moment, and m is called the movement about the horizon. So this equation gives us the relation between the central moment of a random variable when the movements about the horizon are known. Okay. Now we just expand this equation for n is equal to 2. So if you expand this for n is equal to 2, see here this mu n becomes, okay, so if you expand this for n is equal to 2, so mu n becomes mu 2. See here, mu n becomes mu 2. We are writing for n is equal to 2. See this last equation. Now what is the k range? K value is varying from 0 to 2. K value is varying from 0 to 2. Minus 1 power k. What is n here? N is 2, no? 2 ck m1 square. Okay. So m2 minus k. Okay. So it is m1k m2 minus k. Okay. Now if we expand this equation, see here we have m1 power k, no, m1 power k. So here also it is m1 power k. So there is a small mistake here, students. You see, this is not 2, this is k. This is not 2, this is k. Okay. Now we expand this expression for all the values of k. Substitute k is equal to 0. We get minus 1 power 0, 2c 0, m1 power 0, m2, 2 minus k, k value is 0, no? So we get m2. So then substitute k is equal to 1. We get minus 1 power n, 1, 2c1, m1 in m1 power k, no? So m1, m2 minus 1, so m1 we get here, plus substitute k is equal to 2, we get minus 1 square 2c2 m1 square m naught. Okay, so this is the expansion we will be getting. Now we substitute what is 2c0. 2c0 value is 1, no? 2c0 value is 1, and m1 power 0, m1, the first central moment, m1 power 0 value is 1 again, so we left with m2. And what is 2c1? It is 2 factorial divided by 1 factorial into 2 minus 1 factorial, so its value is equal to 2. Then m1 into m1 we get, so it is m1 square. And similarly 2c2, 2c2 value is again 1, so we be left with m1 square m naught. Okay, so and from the properties of variance, see here, this I ask you to copy the time. From the properties of variance, we know that sigma x square value will be, the variance will be equal to m2 minus m1 square. Okay, so we know that m naught is 1, no? M naught is 1. So what is that? We get m2 minus m1 square. Okay. Now similarly we expand this equation for n is equal to 3. So if we expand this equation for n is equal to 3, we get summation k is equal to 0 to 3 minus 1 power k 3ck m1 power k m3 minus k. Okay. So this is the equation we get for n is equal to 3. Okay. Now we just expand that equation. So if we have expanded that equation, we got all these relations. Okay, and from this we know that 3c0, 3c0 value is 1, 3c3 value is also 1. The remaining values we will be found by using n factorial divided by k factorial into n minus k factorial. Okay, now if you substitute the values, what we get? So here we get m3 minus 3 m1 m2 plus 3 m1 square, okay, minus m1 cube. Okay, so this is the formula we get. Now 3m1 if you take common, 3m1 if we take common, we get m2 minus m1 square. So in the previous relation we have discussed that what is m2 minus m1 square is nothing but sigma x square, yes or no? So it is nothing but sigma x square. So here in this place of m2 minus m1 square, we will be substituting sigma x square. So what is mu3 here? Mu3 can be written as mu3 can be written as m3 minus 3m1 sigma x square minus m1 cube. Okay, so this is the relation we will be getting. Okay, so this is the relation we will be getting. Okay, So students, there is again small mistake here. See here, this is m1 cube here. It is m1 cube. Here also we should have m1 cube. So then only we get m1 cube here. Okay. So here it is m1 cube here. Okay, students. Okay. So from that, what is mu 3? Mu 3 is given as, what is m3? M3 is nothing but the third moment about the mean. Okay. So m3 is given as expected value of x3. Okay. So how do you write expected value of x3? Expected value of x3 can be written as x cube, sorry, x cube bar. Expectation is nothing but x cube bar. Okay, so it is x cube bar minus, what is m1? M1 is expected value of x, that can be written as x bar. Okay, sigma x square minus, what is m1? M1 is x bar, so it is x bar cube. Okay, so this is the relation that we get between the central moment and moments about the origin. Okay, now what we do, we just evaluate this mu3 directly. Okay, so what is mu3? It is expected value of x minus x bar cube. Okay, now we just expand this equation, x minus x bar cube, we just expand. If we expand that, we get x cube minus x bar cube minus 3x bar x square plus 3x bar square x. Okay, so this is the equation we get. So now we apply expectation to each and every term. Okay. So if we apply expectation to each and every term, we will be getting expected value of x cube. See here, expected value of x cube minus expected value of x bar cube minus 3 times of expected value of x bar x square plus 3 times of expected value of x bar square and x. Okay, now from the properties of expectation, what is x bar? X bar is a constant. Expectation of a constant will be equal to the same constant. So we will be getting x bar cube only here. So once we obtain the expectation for a constant, we get x bar cube. Okay. So since it is a constant, we will be getting the same constant, that is x bar cube. And here also in the third term, x bar is a constant term. So we write x bar outside. So we'll be getting minus 3x bar expected value of x square plus, and here again x bar square. X bar square is constant, so we will be writing it as plus x bar square. Okay. Now we write what is expectation of x cube is m3. Expectation of x cube is what? It is the third moment about the origin. So it is nothing but m3. Okay, and x bar cube, and we get 3x bar. What is expectation of x square? Expectation of x square. Okay, here we get expectation of x square. Okay, minus x bar square. Okay, again this is what expectation of x is nothing but x bar. No, we get 3x bar cube. Okay, now 3x bar, if you take common, we get expectation of x square minus x bar square. Okay, and we know that expectation of a constant is constant only. So to simplify this, what we do, we have combined these two terms, the last two terms. We have combined these two terms. So we have written it as expectation of x square minus x bar square. Okay. So from this, what we know, this is nothing but what? This is the, okay, so this is nothing but the variance. Okay, so that is why we'll write it as x cube bar minus 3x bar sigma x square minus x bar cube. Okay, so this is the relation we got. Okay, so from this we obtain what is the relation between the central moment and moments about the origin. Okay, so what is mu 3? Mu 3 is nothing but the third central moment. It is also called skew value. So mu 3 is also called skew value.